Okay, welcome to the second semester of Precalc, and the first thing we're going to start with is a little bit of trig and talking about angles versus, and in degrees versus angles that are measured in radians. You guys are all familiar with degrees. If I said that's about 45 degrees, do you know what I'm talking about? And there's just some fussy things we start talking about in Precalc about how the angle is developed. We always start at 0 and we go up from there. Okay, so this was at 0 and we're going up to, let's say, 45 degrees. This is called the terminal side of the angle. Okay, and this is, if you're taking notes, this is the part where you'd probably write terminal. Terminal is where it stops. I'm sure that's not the Latin root word, but I know if I have terminal cancer, my life's about to stop. The side where it stops is called the terminal side. Okay. Now, there is another way to measure angles. There's not just degrees, there's something else. And they're much bigger than degrees. I think you know a degree is a very small little wedge. Okay, that's even probably bigger than 1 degree right there. Okay, but just a warning, I'm going to tell you this up front. If you on your test don't have the degree symbol next to like the 45, if the answer is supposed to be 45 degrees and you don't say degrees, I have to mark it wrong. Why? Because 45 without the degree symbol means 45 radians. All right. So a degree is a little tiny wedge. Barely can see. What's a radian look like? Well, they're pretty big. They're about 60 degrees. It's actually 59 point something degrees. And you'd be like, why on earth would they pick it to be 59 point something degrees? Well, a radian is defined as if you have a circle and you go from the center of the circle out, that's of course called the radius. A radian is defined where this distance from the center of the circle out and this distance to another spot on the circle, of course those radiuses are the same, right? But what's special about a radian is that all 3 sides, including this curve right here, which is called an arc, that arc is also the same exact distance, r. If you get it set up just right, where r, and r are all the same size, then you've got a radian for an angle. This puppy right here is a radian. 1 radian. Now, you should not have to label radians. Again, it's kind of weird. I'm saying it's really important to label. If you say 1 and you don't say anything, I'm going to think you mean radians. Because radians actually don't have a label. Degrees, of course, if I say 1 degree, that would be totally different. That would be like, that is a 1 degree angle, for instance, probably more like 2 or 3, but then I'd say that this angle right there is 1 degree. But if it's in radians, there's no way to label it. You're not supposed to say 1 rad. Nope, don't do that. There is no label on radians. Okay, so you'll see once we start doing trig that radians actually are a really, for trig, they're a really handy way to label things. Okay. Now let's talk about changing over. Let's say I had 30 degrees. You know what a 30-degree angle looks like about, right? Okay. Would you agree that since I said that a radian's about 60 degrees, that this is about half of a radian? Does that make sense? All right. So specifically, we got to figure out exactly how much it is, though. So there's a nice little way to take this 30-degree angle and say how many it would have been in radians, because it wasn't exactly 60, it was like 59 point something degrees. So how do we get it changed over? Anything you want to change from degrees to radians, you want to multiply by a fact. Just to take a little side note for a moment, let's say I wanted to change dollars into yen. If I want to change dollars into yen and I have $25 and I want to change it into yen, do you get that I would need to put dollars on the bottom so that they would cancel and yen on the top? That way the dollars cancels the dollars and my answer will be in yen. Do you get that from science, that you have to have the one on the top and one on the bottom to cancel each other like that? Okay, then I got to multiply by a fact. Let's say that there's 3,000 yen to $1. Now that's how I'd change dollars to yen. Well, it's the same thing for degrees and radians. If I want to change degrees to radians, I got to multiply by a fact, something that's true. And there's a fact about radians that has to do with pi. That's going to be a little confusing for you to begin with, but I'm going to keep it really simple for now. 180 degrees is equal to pi radians. Remember how I said not to label it though? So we don't want to say pi rad. We want to just say pi. Pi is 3.14, right? So 180 degrees, 180 degree angle, I hope you know is an angle that's opened up all the way, right? Are you familiar with that? That would actually be exactly 3.14 radians. You know, like one of the radians would be like here. Here's another wedge that's about that. Here's another wedge that's about that, but there'd be a little left over. 1 radian, 2 radians, 3 radians, plus a little left over. In fact, it's exactly 3.14. All right, that's the part that I said might be a little complicated, but here's the easy part. It's 180 over pi, or pi over 180. That's all you have to do to change between the one and the other, is multiply by 180 over pi, or pi over 180. Now this one that I set up right here, do you get that the degrees would not cancel the way I set it up? And therefore, I'm going to get some number of degrees over pi. And that's not good. So therefore, I better do it this way. Even if I don't even know what the question is, I know that if I want to get degrees to radians or radians to degrees, I have to get my degrees down here so that they will cancel each other. There'll be one on the top and one on the bottom. And what's a fact I know again? That pi goes with 180. So it's either 180 over pi or pi over 180. And remember, you always need to label your little degree sign. Now, this cancels this, so the degrees are gone. The answer is not degrees. Therefore, if it's not in degrees and we just write a number, it's going to be in radians. All right, so how do I finish this deal? 30 times 3.14 divided by 180, pain in the butt, especially since you won't have a calculator for this. So instead, you just leave your answer in terms of pi. You leave a pi in your answer. And then do you get that 30 over 1 and 180 can do a little cross canceling? 30 goes in here once, 30 goes in here 6 times. And now what's my final answer? 1 pi over 6, or 1/6 of a pi. That means 1/6 of 3.14 radians. Believe it or not, within about a week, I'm going to be able to say 30 degrees, and you go, oh yeah, it's pi over 6. Get used to it. It'll be like, this is like one of the main ones we use. 30, 60, and 90 are huge angles, right? And 45 is another big one you use in trig a lot. So you're going to end up memorizing these in radians, because almost all the stuff we're going to do is, we'll start with a little bit of degrees, but it's almost all going to be in radians. It's got to get used to these guys. All right, so 30 goes with pi over 6. There, a typical question on your homework says, take 120 degrees and change it to radians. And you just have to remember, oh, the server said to multiply by a fact. And it's 180 goes with what? Say it. Pi. 180 goes with pi. So then where should I put the 180, on the top or the bottom? On the bottom. That way it'll cancel. And here's my pi. I appreciate some of you are answering out loud. It helps move it along. And then my pi's cancel. And then would you please all reduce that one? Now you're doing this on your iPad, so that way you can turn it my way and tell me what you think the answer is on your iPad. Now, if you're one of the people that really likes to take notes on paper, I'm totally okay with that. But please bring your iPad with you and have it for times like right now, where I want you to get an answer, and then you'd write your answer nice and big on your iPad, and you're going to turn it my way. And I'm going to say, yup, yup, and then, nope, you got to switch this, and then yup, yup. And don't feel bad if I say nope. It's not like, you're wrong. You got to fix your ways, young man. It's just me giving you feedback. And if you know you're doing it wrong, then you can try to change it a little bit. All right, I'm going to pause for a second while I get some of those answers back on the iPad. And again, an ideal answer for this is like, 2 pi over 7 or whatever this reduces to. Okay? And of course, there's a pi in your answer. Now, I'm going to pause for a second while I gather. Okay, so bottom line on this one, what went into 120 and 180? What goes into both of them? 60. 60 goes in here how many times? 2, and 60 goes in here how many times? 3, so therefore it's 2 pi over 3. And you've just changed 120 degrees to 2 pi over 3 radians. And again, you do not label RAD. Something unique about radians is they don't have a label. It's kind of a dumb way to get famous. If you were a brand and your brand was, we don't have a brand. I don't know, that wouldn't sell real well in the real world. But in this math context, that's true. You don't want to give a unit when it's radians. Okay, and I'll explain more about why that is later, but that would take too much time right now. There's only one more thing I need to teach you for today. Otherwise, it's just changing radians to degrees or degrees to radians. And that's a formula. S equals theta R. I'm going to call it SOR. I know that's not an O. It's a theta. But it's just a nice abbreviation, SOR. S equals theta R is the official formula. You'll want to know this one. There's not too many formulas in Precalc you have to memorize, but that's one of them. This is the formula for arc length. And I think it's kind of dumb formula because I think they should have chosen A for arc length, but they didn't. They chose S for the arc length. Okay, so why don't you label this puppy? This is the arc length, ARC length. This is theta is the angle in radians. And this is the radius. Spelled radius wrong there for a second. So let me show you an actual problem. You know how there's water ski boats that have the rope tie off is like right in the middle of the boat on a pedestal. So here's your boat. And they got this pipe sticking up in the middle of the boat. And they tie to that for trick skiers. Because then they can use jet boats and they can like stop on a dime, and the skier, which was way back here, can swing all the way around the boat like this, and they can do this fun trick where the skier actually skis around the boat, and then they can take off again and keep going. It's pretty cool. Anyway, the point is, let's say that you had that kind of scenario where you've got this circle where your skier is going on that outside circle. This is the center, which is tied to the boat, of course. This is the rope that goes to the outside edge. And let's say that they do a 45 degree, now let's make it a simpler one. Let's say it's a 60 degree arc. And this distance right here, how long is a typical water ski rope? Take a guess. I do not have the exact answer, so you can't be wrong. About 40 feet, sounds good. All right. Then obviously this one's 40. And then the question is, what's that one? That's called the arc. So, really what I'm asking you is, how long is this red line right there? And if this was 1 radian, by the way, which it's close to 1 radian, because remember I said a radian is actually 59 degrees-ish, something like that, then this is about 40 feet, but it's not 40 feet because it's not a radian. So it's close to 40 though. How do I find it? It's called S. And we go S equals theta R. Now S is a very simple little formula. All I have to do now is plug in what I know. S is the arc length. I don't know the arc length. Theta is the angle. That's this guy. And the common mistake is to put in 60 right there. But it's the angle in radians. That's why we taught you how to change 60 degrees to radians. You got to multiply by that factor. Remember, we just did it 2 seconds ago. And then the radius is simple. It's 40. So all I have to do is figure out this little calculation, pop it right there, and I'll have S equals theta times R. I'll have solved for S. S will be alone. S will be equal to whatever this is times 40. All right, so let's finish the deal. I've got to multiply this by pi over 180. 60 goes in here once. 60 goes in here 3 times. The degrees cancel too, so it's pi over 3. Look at pi over 3. So it's S equals pi over 3 times 40. So how would I finish that? Pi over 3 times 40 over 1, right? So it's 40 pi over 3. Now remember, if you actually needed a number of feet, we'd actually have to change pi into 3.14159, times it by 40, and then divide by 3, and you'd find that it was just a teeny bit more than 40 feet. And does that make sense? Remember how I said a radian would be if these were all the same? If this is slightly more than a radian, then this must be slightly more than 40 feet. 40 point something feet. Logically, does that make sense to you? All right, so moral of the story, what you learned today. If I give you 20 degrees, you should be able to whip out pi over 180 or 180 over pi and get it changed into what's? Radians. Okay? Then you can use this formula, SOAR. And what's this? Arc length, what's that? The angle in what's? Radians. And this last thing is the radius. All right? Now let's start your worksheet together. I want to pause for a second while we go find it. Okay, so I've called up worksheet 4.1, number 1. We would call that 4.1.1. And now this reminds me of how I said I expect you to do your homework in here. But I also expect the homework assignment to be reasonably sized. And for the amount of time we have left in class, I don't feel like this is reasonably sized. I need to cut it down a bit. So why don't we do for 1 through 16, I think you'd have enough practice if we just did the evens in there. Okay, so 1 through 16, actually it'll turn into 2 through 16, just do evens. All right, so for number 2, 120. Help me out. I'm going to times that by what over what? Is it 180 over pi or pi over 180? It's a pi over 180. Does the units matter? Yes, they're huge. The degrees will cancel, but you need to show that and you need to know that they're gone now. The answer is not in degrees. And 6 goes in, or 6d goes in here twice and here 3 times, and therefore 2 pi over 3. Boom, done. That's in radians, but you would not label it with the word radian, because the big thing about radians is they don't have a label. All right, hit number 4 then, 300, same process, multiply it by either pi over 180 or 180 over pi. In this case, it's pi over 180, because I want the degrees on the bottom to cancel the degrees that are on the top. Doink, doink. Because in both of them, 60s are a really good thing to know. 30s are another good thing to know. If I want to do 30, I can do that. 30 goes in here 10 times, and 30 goes in here 6 times. And then I have to reduce it again then. What goes into both 10 and 6? 2. 2 goes in here 5 times. 2 goes in here 3 times. So it's 5 pi over 3. I think you're getting the idea there. All right, let's move on to convert from radians to degrees. He never showed us that. Well, it's the same exact thing. You just got to multiply by a fraction, except this time instead of pi over 180, it's 180 over pi. So if I'm going to do the evens here too, that would seem reasonable to me. Let's just do the evens here. This one's, what did I say again? Pi over 180 or 180 over pi? And why would I be able to tell? Because the pi, something's got to cancel. If you're changing from something to something else, something's got to cancel. And remember, I'm supposed to have units on this. This is supposed to be 180 degrees. That way, when my pi's cancel, my answer will be degrees. 180 degrees divided by 4. The question really is, how many times does 4 go into that? I like to think of it this way. 2 goes into both of them. 90 degrees over 2. And then I can do it again. What? Oh, 2 goes into 90, 45. So I go 45 degrees. There we go. Okay. So there's radians to degrees. Now let's move to the last part of the worksheet. And that's talking about use the arc length formula to find the missing information. All right. And there's a few word problems at the end. Again, in here, given how much time we spent on the get to know you stuff, we're going to continue to do evens all the way up through, I think you should do both 33 and 34, but we'll do the evens in this area here. So we'll do 26, for instance, here. That's one of the evens. So if I'm going to do 26, and for those that can't read this at home, this says, what letter is that? I can't read it myself. Thank you, S. That's also known as the arc length. And this is R, the radius. So they have given me that the radius is 1, and that theta, no units means it's in radians, is 70. Well, I'm going to whip out the formula that I know. S equals theta R. And I'm going to stick in what I know. They told me the radius is 1, putting in a 1. They told me the angle is 70, putting in a 70. Looks like I'm figuring out S. S equals 70 times 1, which is what? 70. There we go. 70. Now, this is a bad worksheet because, well, it's not terrible. It's just there's no room for you to show your work. Do I want you to show work? Yeah, I do. Remember, we're only doing the evens, so if you want to show your work right over the area where you do the odds, you know, that'd be a good place to show your work because we don't use that space. Yes, ma'am? That's a good question. I did not put units on my original problem. I really should have said 1 cm. Can't see you read the black over the black, but you're right. It is 70 centimeters. And yes, you should have units on your answer. We really haven't had too many problems that have units as a big deal. These units are kind of a big deal. And I'd hate to have mark them wrong on the test for you because I get you could have everything right and just forget the cm and all of a sudden lose points. So thanks for reminding me of that. Yes, we do want your units. On your homework, it's not that big of a deal. On your test, it's tragic if you lose 10% of your grade because you forgot to put a little degree symbol. Okay, so just be extra paranoid on units. It's really rare, actually, that somebody does make a mistake on it, but it's because we pound and remind you and remind you. Okay, so the only other one here is that it's like challenging is this bottom section, and it's talking about concentric circles. If you don't know what they are, concentric circles are circles inside of other circles. They're like this. They have the same exact center. All right, so this will take you a moment to set up, but this is not impossible at all. You just got to draw yourself 2 circles, one inside the other, and therefore there's 2 radiuses, right? So this is one of your harder questions on the homework. Just got to label this right. This is radius 1. The bigger one will be R2. And then it tells you, okay, if R1, the smaller radius, is 11, figure out theta, the angle that would go with it. The bigger radius is 44. Anyway, the S sub 1 is the arc length on the smaller circle, and this S sub 2 is the arc on the bigger circle. A picture is worth 1,000 words. My picture is terrible. It hasn't been labeled well. I need more space. Do a good picture, and it'll make it so much easier to answer that question. That's one of my best tips on word problems is draw yourself a good picture. All right, and then down to the last 3, 35, 36, and 37. Again, they've got an example of concentric circles here. This should be going all the way to the center, I believe. Oh, no, it doesn't say that. It says they are 6 inches apart, as in just from here to here is 6 inches. That's different than to the center. The inner circle has a circumference of, oh, I better give you a circumference formula for a circle. I bet some of you know it and some of you don't. What's the circumference formula for a circle? C equals what? Somebody whip it out. What is it? Pi times diameter. Circumference is pi times the diameter. So if I know that, you always start with the pure form of a formula, and then you stick in what you know. I know the circumference is 37.7 equals pi. I know pi, 3.14, times d. Therefore, I know what the diameter of that circle is, right? If you start with a formula like this and just plug in what you know, of course you can then solve it. The only trick to that one is thinking, well, I don't know what pi is. Sure you do. It's 3.14. All right. And I would be okay with you leaving your answer in terms of pi. So in other words, if I divided by pi on both sides, it would be 37.7 divided by pi is the diameter. All right, I think I'm not going to be giving you that thorough of help with your worksheets every time, but I do like to start them with you at least. But now we've covered all the way through the end and even give you a tip on one of the hard ones. So the amount of homework that you have left is, I think, a reasonable amount, so such that even though we don't have too much time in class, hopefully about 20 minutes at home, and you got this thing done, and you come back to class and you find out that I really do record them and grade them and put them in the grade book. So tomorrow, have it done. And if you do, if you check your answers online, a lot of the ones I will pick to grade will be one of the ones that the answers were online. Some I picked without answers because I want to check to make sure you're not just skipping those. But if you've checked your answers, you're going to get a few right for sure. Okay, and I'm hoping the five that I check, there'll be lots of 4s out of 5 in here, at least, for a grade. Okay, so please get your homework done. It'll be our first chance to for you to have a grade in the grade book, and I'd love it to be a good score. I won't pick the hardest ones either to put in the grade book for your first time. So, okay, that's all I got for you for today. Say